we'll end with this graph right here showing the rate of near-Earth asteroid discoveries. So there's a lot more to learn from this, but I think at this point, maybe we're starting to get the point. The point is simply that we're living on a vulnerable planet. We're seeing a planet now that when we look out into space, we see that there's a hell of a lot more stuff out there in the near-Earth space region than anybody had imagined even a few decades ago. We're also finding out that the history of life on this planet is regularly punctuated by these gigantic catastrophic events. We're also finding out that the entire planetary surface is pockmarked with scars of huge numbers of impacts. We're also discovering that there is evidence that there could be multiple Tunguska type events. Important point. The objects that the iron objects, like that created the crater in Arizona, relative to lighter density Tunguska type objects, the lighter density Tunguska objects are far more prevalent, maybe 10 times more. For every one object, then, say that's below 500 or 1,000 feet in diameter, there might be 5 to 10 objects of the Tunguska mass, Tunguska mass and density. So you see what I'm getting at here? There could be a far greater danger of Tunguska type events than anybody has appreciated. And why they're not looking at this, I don't know. But I'm guessing that the B12 Society is probably looking at it. I know a lot of members of the Comet research team are looking at it. I know George Howard is looking at it, who we've had on the show, and realizing, you know what, we really are far more vulnerable. And then the final thing is we're seeing in the evolution of human civilization on Earth is also punctuated by these repeated interruptions. Well, what's causing those? That brings us back to the question of extrinsic or intrinsic forces. A lot of evidence is pointing towards extrinsic forces being the ultimate trigger. Now, something happens from the outside that destabilizes society, yes, then there may be an intrinsic reaction or consequence to that, because it may trigger a destabilization that doesn't immediately drop the hammer on the civilization. It may be a destabilization that takes a generation, 2 or 3 to even recover from, if it does at all, you see? So the problem here is that the vast majority of humans on this planet are oblivious to the bigger world that we're a part of. That's the problem. Mainstream media is not helping, because what we've got here is hardcore evidence, and we're just barely touching upon the surface of this type of evidence. But what's everybody worried about? Look at the stuff people are worrying about. Oh, we're all doomed because of a minuscule increase in carbon dioxide from 300 to 400 parts per million. That ain't much, folks. Is that really going to trigger catastrophic global warming? And that is a very fair question to ask. Now, is there consequences from an increase of 1 molecule of carbon dioxide for every 10,000 molecules of air? Yeah. Is it catastrophic? I think to be skeptical of that is a certainly legitimate stance to take. And when you begin to look at it, you go, there is a downside. But also there's an upside, because a little bit of extra carbon dioxide, as we now know, is fueling plant growth worldwide. It's literally causing a greening of the planet. And we're going to talk about that. And we're going to look at some of the evidence and the satellite surveys and stuff that have led to that conclusion. But in either case, my point is that we are neglecting what really could be the most dangerous natural phenomena in our future. And it's a phenomena that encompasses all of the others, because a major impact can have secondary consequences that would mimic every single, like, for example, an earthquake. At this point, an earthquake happens. What can we do about an earthquake, right? Well, an earthquake can be a pretty severe thing, or a volcano going off, right? Or a tsunami, right? We've seen within the last 20 years how we've had 2 devastating tsunamis, right? That were caused by undersea earthquakes. Hurricanes, right? At this point, a hurricane is a natural phenomena, right? And it can cause severe economic disruption. It can take many lives. So you look at hurricanes, tsunamis, earthquakes, volcanoes. Okay, every single one of those can be a byproduct of an impact. Every one of them. See, an impact can cause severe seismic activity around the planet. It can induce volcanic eruptions on a tremendous scale. Obviously, an impact into an ocean. Like we just read, a tsunami wave that could be 100 meters or 200 meters high. What the hell is that going to do when it makes landfall? You know, what's going to happen to Florida? What's going to happen to the East Coast if you had a tsunami 200 feet high coming in making landfall? Right? Well, this is not science fiction. That's the point. You see, there have been a lot of civilizations before us that have risen out of the organic matrix of nature, have existed for a while, and then they've disappeared. Why have they disappeared? Again, it gets to that question, intrinsic or extrinsic. And I think that what we can safely say now is the evidence is pointing us directly towards, in a lot of the cases, extrinsic factors, if not being the death knell for a specific society, at least the trigger mechanism that destabilized them to the point where recovery may have been impossible. You see what I'm getting at here? So if we do not become cognizant of this larger, bigger, this cosmic environment that we are very realistically a part of, I think it's very probable that we could go the way of previous civilizations. If, on the other hand, enough people can say, look, we really do need to look at the big picture. Enough people around the world, if we can get a few million people to watch stuff like this, that can look at the research of the Comet research team, look at the goals of the B612, to listen to Ben Davidson's on the sun. And we're now, of course, seeing that there might be a connection between the influx of this kind of material and the activity of the sun. We're going to address that, right? The sun-grazing comets and the connection between the infall of sun-grazing comets and heliospheric earthquakes, or I'll say sunquakes, coronal mass ejections. There could possibly be, it's looking like now, a correlation, because it's looking like the solar system is functioning as a whole unit. And things don't happen in isolation, like we probably have imagined, that something that can affect the entire solar system. And I think that what we're going to be doing is when we come back around, we really begin to look again at the whole, this array of incredible and mysterious phenomena that characterizes the Younger Dryas, that we might have to actually be going, what we're seeing here is the terrestrial manifestation of a solar system-wide event. And it might be very realistic and helpful if we started, for example, looking at the moon or Mars to see if there's anything on either of those two bodies that could actually correlate with the Younger Dryas on Earth.
That's really cool idea.
And I think that one of the insights, just like so much of the insight that we can now apply to the solution of modern scientific problems, comes from ancient perspectives. You know, when we start talking about megafloods, it can be tremendously helpful to look at ancient accounts of megafloods that are from all over the world, realizing that these aren't just made up things by superstitious pre-scientific illiterates, but are actually stylized ways of preserving these stories about actual events that people lived through, right? But extrapolating from that, we can talk about, okay, yeah, there's evidences of stories, all kinds of stories about cataclysmic events in Earth history involving both floods and fires, right? As well as huge earthquakes and upheavals and so forth. And now we're realizing that that geomythic realm is actually perpetuating really valid scientific information, right? Well, if we accept that there is scientific validity to looking at mythology to try to get greater insight to things that our ancient ancestors might have been experiencing, could we apply that to the discussion of, say, gods who are coming from the sky? Because the myths are full of, from all over the world, accounts of gods from the sky. Now, what does that mean? And that's, I think, worthy of looking at. And I think we should come to it, kind of try to strip ourselves of all preconceptions and then take a fresh look at some of those myths. especially, well, I mean, look at the Sumerian myth. Here we have the myth of global destruction tied directly into an emigration of the Sumerian gods, don't we? What is actually, so the question is there some kind of a real event behind those stories who the actual nature of we may be able to get greater insight into by looking at those stories in detail and maybe without the preconceived ideas? I think possibly yes. So we definitely should come back to that idea at some point, but not until we've laid the groundwork. You know, we're not talking about putting up the rafters until, you know, long after the foundation has been set down. And that's what we're doing now, is we're building a foundation of information and knowledge that I think we can build upon to understand a whole lot of other things: mass extinctions, climate change, the rise and fall of civilizations, maybe accelerated biotic processes, such as we will learn about when we go back to Tunguska, because we see accelerated evolution in the aftermath of the Tunguska event. And then, of course, the idea of what are these stories about the gods of the sky? On the one hand, we maybe is it a metaphor simply for a cosmic event that could be explained purely by naturalistic and non-anthropogenic phenomena? Or is there something more?